So today is lesson 13. It's our last lesson. Vishal, did you mean to click on annotate? Or was that an accident? Oh, okay. All right. Well, if you feel that you need to make some notes, then go ahead. Not a problem. Okay, so what are we doing today? We're going to talk about our final exam, which will be in next week's class. And then we're going to work with Web API in ASP.NET. Today's class will be short. I promise we will definitely be done. I promise to set you free by 1 p.m. today. I know you're probably busy finishing. I assume you still have assignments in some other classes to get done. We're pretty much done with the assignments in this class other than a quiz. But I know you probably have some other work to do, and we can probably hammer through Web API in a couple of hours. Should be enough time. So we're going to review what we already know about APIs. You've worked with them a little bit before, but we're going to work with them in the .NET context today. We're going to use scaffolding to build a Web API controller, and then we're going to use some tools. I will recommend Postman that we can use for testing our API. And then lastly, we're going to look at the Open API specification and a neat tool called Swagger. What Swagger does is it will generate documentation that describes how our API works. Whenever someone is going to consume an API, the first thing we do, when we were working with Stripe, for example, we'd go and read the docs on the Stripe site to learn how do we integrate the Stripe API into our application. Morning, Bina. I think I owe you an email. Actually, Bina, sorry, I did see your email, so that's fine. Yes, I got your email. So we'll look at using the Swagger tools for documenting our APIs. So I'll talk a little bit about next week's exam, and I'm happy to answer any questions that you might have. So exam is done in our normal class time, so I will be sure to open up the WebEx room by 10:50. And I will go over the instructions of the exam one time at 11 o'clock. Excellent calendar management skills. You can breathe easy, Yulia. So Yulia, you were on time today because you thought we had an exam. No exam today, but good for you for being here. I know, I'm just teasing you. You are on time. A lot of you are on time, which I appreciate. Saves me from having to repeat myself. So the format of next week's exam, it will be similar to the midterm exam in terms of format. It will be all practical. Well, you've got exams this week. Okay, I didn't realize you had exams this week. So it's all practical. Now, I may ask you to build a project from scratch. I might also provide a starter project for you on GitHub that you would download and then you would make changes to. Okay, you will not need to use Azure or Smarter ASP. So for the database, I will probably give you a shared database like I did in the midterm exam. So you're not going to have to create a database for the exam. Okay, or if you do, it will just be a local database. Okay, anything we've covered in the course could be included for marks on the exam, with the exception of Stripe payment. Stripe will absolutely not be part of the exam. If Stripe is in the exam, it will be in the starter project and I will have already included it and you won't have to change it or touch it. Okay, so I'm not evaluating you on incorporating the Stripe API at all. There will be multiple versions of the final exam, much like there were with the midterm exam. There were multiple versions. Okay? And again, just like in the midterm, I will ask you and gently remind you every 30 minutes to commit your work to GitHub. And you'll want to be in the WebEx room so that you can ask me any questions in the chat if you need clarification on any of the requirements. Yes, so Mihir, the exam will focus more on the second half of the course because we did have a midterm exam. So, I mean, a few of the basic things, there will be some easy marks for doing some basic things that were covered in the first half of the class, but the focus will be on the things we've done primarily in the second half of the course. So that means authentication, um, maybe session management, unit testing, and web API. Yes, Drew, unit testing will definitely be part of the exam. I can tell you unit testing and web API absolutely are part of it. You will definitely have to do those things. Are there any other questions about your exam? Yes, Sweetan, it is possible. One thing I would recommend in terms of studying is what I would recommend is for assignment 4, you only had to pick one method. So probably most of you picked a fairly simple method. Not everyone, but a lot of you may have picked a simple method for writing your unit test. What I would recommend, a really good way to practice unit testing for the exam, is try writing unit tests for some of the other methods that you didn't choose for assignment 4 and you didn't do in your lab activity in class last week. So if you haven't done any of the post methods, they're a little more complicated. So work with the classmate and see if you can try to do the unit test for one of the post methods. Okay, Attila, so you're well prepared if you did them all. So that would be one useful way of studying is work with a friend or two in the class and work on unit testing some of the other methods that maybe you didn't do for assignment 4. Are there any other questions about the exam? So I'm really testing two things. Okay, thanks, Mihir. I'm not there. There aren't tricks on the exam. I want to check the basic concepts we've covered in class, but I also want to check your ability to kind of apply those concepts maybe to slightly different contexts. So, we may have done it like this in class, and then you've got a slightly different scenario in the exam that you now have to adapt that method or that technique or that tool to during the exam. Okay. All right. So we're going to be working with we've worked with APIs already in our class. If we open up our project, we could open up. Oh yes, absolutely. Postman is just an option for sure. We'll talk about that. You're a little bit ahead of me, Attila, but the short answer is yes. So let's open up our global grub shop. Just get it running. So we've already done some work with APIs in this project, but we've been doing them from a consumer point of view, right? We are using APIs built by other applications to extend the functionality of our application. So what APIs are we consuming in our shop? I think we're consuming 3 APIs. What are the 3 that we're using? All right, Manjinder gets right to the point. Right, we've got Stripe for payment. We've got Google and Facebook for sign in. So in each case, we are the consumer, right? We're using their service. So in order to use them, right, for example, for Stripe, we went to the documentation and it gave us sample code. It tells us how do we integrate with their API. Okay, we're going to briefly, we're going to do a little bit of, we're going to define a few important terms. So we're going to use, I'm going to pause the recording for just a minute. I'm going to create 5 breakout groups. This is just going to be a very short activity. You're going to have 5 minutes only in the breakout groups. You can join any of the breakout groups. Actually, you know what, to make it easy? Oh, sorry, you'll just be assigned. You'll be assigned to one of 5 groups. If you're in group 1, I want you to give us a simple definition of what an API is. If you're in group 2, you're going to define the term REST. Group 3 is going to define the term PUT. Group 4 is going to define the term URI. And group 5 is going to define the HTTP status code of 400. Don't just copy and paste the definition from Wikipedia or the first Google search result. I want a common everyday language definition that a non-technical person, like someone in your family, could understand. Okay? And I'm only going to allow like 5 minutes max for this. And then when we come back, I'm going to ask each group to share their definition of their term. Okay, so I'm going to pause the recording. Okay, so our 5 minutes in our breakout rooms are up. So I'm going to ask if somebody from group 1 could post in the chat, what was your definition, kind of your simple definition of an API? I'm going to throw it up into Blackboard. Okay. Thanks, Manjinder. So it allows 2 different applications to communicate, serves an intermediate, retrieves the user request, delivers it to the program, and gives a result back. Okay. It's also a way of restricting the method. It's a way of restricting the method of accessing your application by providing sets of methods designed by third parties. This way, the third party using our application has restricted access to our data. Okay. That's a great definition. Did you have an example in mind, or could you think of what kind of API would meet that definition? Where we have access to data in another application, but in a restricted way. Can anybody think of an API that this would describe? Okay, yeah. Okay, Google does it. Yep, right. Or Facebook, right? We don't have full access, for example, with Google login. We just have access to a certain amount. We can't see someone's full profile. Okay, like a police record, maybe. Attila, okay, with banking. What kind of bank API are you thinking about, Attila?
Any API we can retrieve our account information or create a new transaction.
Okay.
So to interact with the bank system.
Okay. Yep. All those are excellent examples. Okay. All right. Thanks, Group 1. Really good answers and examples. What about Group 2? We've got the acronym REST. Somebody tell us what REST means.
Attila, do you want to go? To be honest, personally, 5 minutes was not enough to quite understand REST.
Okay.
But Attila is already very familiar with it, so I'm sure he
Yeah.
can give an explanation.
Okay.
Yeah, we made lots of notes. Alexis shared our notes. So it's REST. It's the acronym. It's a representational state transfer. So the REST is the common way how we can share the data between one of two systems.
Yep. So I would agree. I'm going to add one word to that, Attila, just to help flesh it out. I think that's good. REST is a common pattern
Yes.
for API structure, right? Much like we're using the MVC pattern for our web application, REST is the kind of default standard. So it's the current standard. The old standard was called SOAP.
SOAP or Corba or
Yeah.
its own.
Okay, so REST is a way, it's a pattern for structuring our APIs. REST also tends to use what
JSON
format? Yeah, so data is typically exchanged in JSON format. So again, SOAP typically used XML format. So two systems written in different programming languages could communicate by sending messages before in XML, but in REST, data is typically exchanged in JSON format.
and predict the CRUD endpoints. So it's any REST API should have or must have the CRUD method or functionality, which means create, read, update, and delete, and then options as well.
That's right. So they follow along a CRUD pattern, typically. So most REST APIs, instead of the method names being totally up to the developers, that most of the methods follow create, read, update, and delete. So they follow a pattern. Okay, and we'll look a little more carefully at the REST pattern shortly. Okay, thank you, group 2. How about group 3? This one's a little bit simpler. What does put mean in the context of a REST API? Okay, thanks, Shisato. I'm going to copy and paste that and we can kind of go through it. Excellent answer. So in REST APIs, users make HTTP requests for performing CRUD, as group 2 pointed out. We can use put and post for creating resources, but typically post is for creating a new resource. Put is usually for updating. So when we look at REST APIs, we'll usually see get methods for reading, post methods for creating data, delete methods for deleting, and when we're updating, the HTTP method we're going to use is called put. All right, thanks, group 3. What about URI? What is a URI? Okay, thank you, Nat. So it stands for a universal resource identifier. So something like a string that's used to identify a resource from a particular name or location. Okay, so here's the $1 million question. Great job interview question. If I was hiring a developer out of school or for co-op, here would be my question. What's the difference between a URI and a URL? They're similar, but they're not exactly the same. Anybody have an idea what the distinction is between a URI and a URL? You're also welcome to take a guess if you're not sure. I'm sure you're all searching furiously.
Shows the entry point in an API.
Okay, so that's true, yes. So it's used to represent the endpoint of one API method, of an API method, yeah. So that's true, Marcos. It is the endpoint. But what about the relationship between a URI and a URL? There's a connection there, but they're not exactly the same thing.
So a URL is part of a URI, I
It's
believe.
a good guess, Alex. And Jesse's saying URI points to a specific page, URL points to the domain as a whole. You're close, Jesse. Vishal said URL is a location of a resource. That's true. And Jinder says one is identifying the resource, and the locator only gives out the location of the resource. We're sort of dancing around it. I'll give you a hint, and then see if you can flesh it out. All URLs are URIs, but not all URIs are URLs. So a URL, that's right, Vishal, you got it. A URL is a subset. It's a type of URI, but not every URI is a URL. So could you think of an example of a URI that is not a URL? So Vishal has got it exactly. So URLs are subsets, a subset. That's right, Aftab. Well, a URI, not exactly. A URI can be a URL, but it doesn't have to be. A URL is, by definition, a URI. It's unique. Okay, so why is this? So URLs are HTTP-based URIs, right? They start with HTTP or HTTPS. It's a path to a resource that is available by HTTP. Some URIs are not HTTP based and therefore not URLs. So yes, for example, a file path could be a URI, but that file path is not using HTTP. So in that case, it would be a URI, but it's not a URL. So for example, if you're building something like a mobile app, you may have images that are loaded from storage. So the path to those image files is a URI, but it's not a URL. It's not HTTP based. You could not use a browser to access those resources. So in REST APIs, we use URIs as the endpoints of our methods, but it's important to understand the distinction that it's not necessarily, that URI and URL, they're not exactly interchangeable. Okay? They're not completely the same thing. Okay, and group 5, you got probably the easiest one, an HTTP status code of 400. Okay, thank you, Jesse. Okay, yes, so the 400, it indicates an error in some HTTP requests. So a 404 is a more specific one where you tried to access a page or a resource. May not be a page, it might be a resource like a media file. So we should be clear we look at HTTP stats. So here from Mozilla, right, we can see, so the 400 to 499, these are all client errors. So 400 is actually a bad request, right? So there's some kind of problem in the request we're making. So I'm just going to add that. So 404 is a subset. So this is typically because of a syntax error in the HTTP request. Yep, so it could be the URL is badly formed. Yep, it could also be, let's say we're doing a post request. Let's say we're doing a post request, or we're passing in a parameter that parameter is not formatted properly. Like maybe we're calling a details method with an ID, we pass in a string. Or if we're posting a JSON object and we're missing a quote or a comma or a bracket. So our JSON is not properly formed. That would generate, we'll try this, that'll generate a 400 response. So misformed URLs, invalid parameters, improperly formatted request bodies. So any of those, any problems with our request is going to generate a 400 response. So so we'll look a little bit at how these things work together. Let's just look at REST API for a moment. Here's a simple tutorial. Okay, so we've got here are our methods, right? So we said we've got get, put, post, and delete, and these map to our CRUD operations. That's not very useful. Okay, let's look at a common API, even better. Let's look at the API reference for Spotify. Let's go here to the reference. I'll put the link in the chat. So here's an example of a common API, right? Spotify lets us view some of the data and include it in our own applications if we want to, but obviously we don't have direct access to their database. So how does their API work? So they've documented it nicely. So if we wanted to use it, we can read the docs. So it says the base URI. So all web requests will go to HTTPS because it's secure, api.spotify.com, and it's v1. So later on when they make a new version, they may change that endpoint to v2. And in the endpoint, so let's say we want to get something like artists. Right? If we want to get a single artist, it tells us we can click on the documentation, gives us a description. This is what this method does. It gives us information from the Spotify database about a single artist identified by their unique ID. So to try this out, we would make a GET request at api.spotify.com/v1/artists. And then we've got an ID parameter, which is actually a string, and they give us a sample value. And the responses that we might get back, we could get a 200 an OK response that will return an artist object in JSON format. And there's a sample over here. This is what it would look like. They've then got some errors. Now this API is not public. You can see here it's got this little secure sign. It uses OAuth. So you need an authentication token for this to work. So if we try calling this API without an authentication token, we're going to get a 401 response. We might get a 403, so a bad request if there's something wrong with the token, or We've exceeded the rate limits because we can only make so many calls to the API. So I could actually try this right here in my browser. I could try making a call and see what happens. api.spotify.com v1 lists. And I'll just go take their sample. What do you think is going to happen when I try and call the API? Any predictions? What kind of response? Manjinder thinks 401. Yeah, well, that seems to be the consensus. Well, let's see, right? I get 401 because I don't have an authentication token. I can use my browser to actually make a GET request here. But it's saying, yeah, you got to provide a token. We're not going to have time to get into the token management, but we're going to build an API that's just public. We'll leave the tokens out for today because I just don't think we've got time to do it. It's a little more involved. Okay, so what we want to do is we're going to build a simple API into our food shop. Visual Studio, as it does with many things, makes this very easy. So make sure you've opened up your Global Grub project and go to your Solution Explorer. And once you have it open, I want you to open up your controllers. I'm going to right-click my controllers folder, and I'm going to add a new folder inside of it, which I'll call, just in lowercase, API. Okay, so I'm going to make this folder. So I'm going to separate out the API controller we're going to build. I want to separate it from the web controllers. So all the controllers we've already built, they live right in the root of the controllers folder. But we're going to make a new controller inside of our API folder. So now I'm going to right-click my new API folder. I'm going to add a controller. And when our scaffold pops up, right, it defaults to an MVC controller. This is what we've been using all semester long. We've used empty and we've used controller with views, but we don't want an MVC controller. What option do you think we should pick instead? Remember, our API, it has no front end. It's just a service. That's right, it's ELMR. We're going to pick API, and then we get the options: an empty API controller, API with read write. We want API controller with actions using entity framework. And then we get this description on the right that tells us what this actually means. An API controller with REST actions to create, read, update, delete, and list entries from an entity framework context. Well, that's exactly what we want. So we're going to pick that third option, API controller with actions using entity framework, and click add. Our model is going to be the product model. So yes, we already have a file here called products controller, but this one is going inside of the API folder. So that's okay. We're going to have two different files called products controller, but they'll be in two separate folders. So my model will be product. The data context should default to our application DB context. That's the only database connection we have. And the name, again, will default to products controller. So I'm just going to leave those two options and click add. And we'll let Visual Studio scaffold out our controller. Now this looks a fair bit like our other products controller. Okay, here's the products controller we scaffolded back in lesson 4. What differences do you notice? There are a few things different about our new controller. Yep, so you're going to create, under controllers, first create an API folder. You just right click, add new folder, and call the new folder API. Once you've got your new folder, you're going to right click it and choose add controller. You pick API. You're going to pick an API controller with actions. And then you simply will pick your product class as the model. Okay? Okay, so Attila mentioned, yeah, in our return statements, it's not returning any views. The only thing that's being returned is JSON. Okay, so that's one difference. Yuli, I'll come to your question in a minute. What else do you see that's different in our API, in this controller from our original? Yes, Ness, so it's returning here, right? It just returns the product. It doesn't return a view. So what now I'm going to ask you, what format do you think this is in? If it returns a product, you got it again. It's JSON, right? So all of these methods just return data in JSON format. So here we're returning a product. Here, after we do an update, right, in our web browser, in our web application, we do a redirect. But here, this just returns a status of 204. It doesn't return any data after we do an update. So we're returning no content, but with a 204, which is an OK response. Okay. Anything else you notice that's different about this controller? Okay, that's a good question, Manjinder. How does it know to use JSON for this? The clue is in the middle of my screen, the answer to your question, Manjinder. Yuli, I haven't forgotten your question, but I just want to go through the controller first. What on here would indicate that all the methods just return JSON? Good guess, Marcos. Yes, Yulia, you got it. Line 14, right? Because we've declared it as an API controller, right, it inherits. So when it's an API controller, that means by default, all of the response types will be JSON. Okay, Manjinder? So that's how it knows, because we're doing an API controller. So we've got this. The root is also a little different, right? Our controller name is prefixed with /API. We've also got above our methods, right? Notice here, we've got HTTP put. Well, we haven't used that before. So far, we only used, in our web controller, we only used get and post methods. So these were all get, and then we also had post methods, get and post. In our API, we've got get for reading. So we have two get methods, right? Get all the products or get a single product. And you can see we've got HTTP get annotated above each one. The put, the update method, has HTTP put with an ID parameter. Post is for creating. And we've also got an HTTP delete. that returns no content also. Okay, Yulia, you asked about the locks here. Why do we have... Okay, the locking, this is kind of an old, I believe this is for work with Team Explorer. Sorry, it's not Team Explorer. Visual Studio includes, it's kind of leftover from an old version control system that I used so many years ago, I can't even remember it. But notice when I put my mouse over it, says checked in. I'm trying to remember what the, Microsoft used to have a version control system before we used GitHub widely called Visual Source Safe. I used it a long time ago. With Source Safe, the idea was when you were working as a team remotely, we could work on a project and we could check files in and out. So if I checked out a file, let's say Yulia, you, me, and Manjinder were all working together. If I was going to work on this file, I could check it out. And then in your Visual Studio, it would show as checked out so that you could only take out a read-only, you could only open a read-only copy. So that way you could open the file and you could look at it, but you couldn't save changes until I checked it back in. Now, Visual Source Safe doesn't exist anymore. So I'll be honest, I'm not entirely sure. Let's see if there's any. I haven't used this like checkout feature in like 15 years. So I'm not entirely sure why it's even here still. Yeah. Oh, now I've got it by the API folder. Took a minute, and now it's here. So it's checked in, meaning like I have access. I don't even know how we would check them out anymore. I'm not even sure. It's a bit of a legacy thing. I'm sure there's an answer, a better answer here. But I don't honestly know. Been so long since I've used that check-in, check-out system, I don't even know anymore. I think that's what it's related to. Locking files, so if we're sharing the project, yeah, no, nothing for us to worry about. Thank you, Amar. The file is not editable by Visual Studio. It comes when you ask Visual to navigate to a definition that exists only in metadata. Show a padlock to indicate that you can't edit it. So which file? I don't fully understand that definition, but thank you. It would make a lot of sense to me because I can edit the files. But anyway, we'll move on. Okay, so very quickly, if I just build the solution, we could actually start to try out the methods of our API. So if we wanted to run the first method in the controller, if we wanted to run this get method that will return a list of products in JSON format, how could we very simply do it? Right? Remember, every REST API method has a URI. It has an endpoint. So what endpoint would we go to call this API method? Could actually do it in our browser. Right, we could just go to API/products. So I'll just copy that, jump up to our browser, and we'll go to our root domain. Thanks, Attila. And now our API fetches all of our data in JSON format. Cool. So it's calling our first get method that gives us a list of products automatically formatted as JSON. What if we wanted to select a single product, like going to the details view in our web application? How would we do that? What would the endpoint be if we don't want the full list? So this gives us the full list. We can see it fetches all the products. But we've also got a second get method that allows us, we could just pass in an ID. So I see product ID 2 here, which is a croissant. So this is like the API equivalent of the details method in our web controller. What will happen if I do this? What kind of response would you expect? If I put in an ID number, right, we get a 404 not found. Because in the scaffold, right, it takes our ID, it calls find. But if the product is null, it returns that 404 HTTP status code. Right, so it either returns a 404 or it returns the JSON object. And we should get a 200 response if I turn on my network tools. Right, in the headers, can I see my response? Let's see if I go to my, we'll take a break in just a second. I'll just turn on my developer tools and go to network. So we can see I get a 200 response, an OK, with a valid ID. With an invalid ID, right, it gives me a 404 response. So 2 seconds, we have a working API. Now we haven't had a chance to test out the other methods of the API. We know that the 2 get methods work. We're going to want to make a little change to this method, and then we'll also want to test out the add, edit, delete methods of our API as well. So we will do that, and then once we test those out, we're going to use Swagger to build an API documentation file, kind of like this one. Okay, so let's take a break here. We will come back at 12:05, and we'll be able to do those things. We'll definitely be able to wrap up by 1 o'clock, if not earlier today. Okay, let's take a 10-minute break here. We'll be back at 12:05.